Okay, so good afternoon to everyone. My name is Fernando. Let me start saying that I relate very much with the idea that Diogo told us that you should be an eternal student. Actually, I'm still a student. I'm finishing my PhD in Técnico here in Lisbon. And what I'm doing is not very much related with the previous presentation. So I'm also programming a lot. I'm doing a lot of software. But my goal is to develop tools that help us to understand social dynamics and our social behaviors. Okay. So what I'm going to show you in this work, in this presentation, is a very recent work that tries to approach this question of how simple can a moral code be and yet still promote cooperation in a society. Before going to this work, I will present you two studies that I think that are really interesting and related with this topic. Okay. So the first one actually involves babies. So in this study from 2011, some researchers from the US, they brought some babies to the lab and they showed them a play with some puppets. Okay? And in these plays, you have characters that are trying to open a box, and then other character comes and helps to open the box. Or you have other characters that come and that refuse to help open the box. So you have a bad puppet and a good puppet, let's say. Then after this very simple play, you have another character that will arrive and that will either help the bad puppet or refuse to help the bad puppet, and help the good puppet or refuse to help the good puppet. And then in the end of this situation, the puppets are presented to the baby, and the baby has to pick one. And what's interesting is that systematically, these infants, and they are 8 and 5 months old, they prefer those that were helpful, but they also prefer those that refuse to help the bad puppet. So this means that when we are young as 8 months old, we already have some kind of moral judgment. We already try to tell apart what is wrong and what is right. Okay? In the next study that I'm going to tell you about, and this is a very recent study from last year, in this study, a research group from Italy, they wanted to understand the relationship between some of our conversations and the hormone levels that we have. So what they did was that they recruit 22 people, and one by one these people were placed in a waiting room, and then they didn't know what was about the study. But then there was someone hired by these researchers that started talking with these participants. And the conversation could be either about gossip, so something about other person, so kushkis, okay, and could also be about any other topic. Okay, something related with an event in the past. Now, what these researchers found was that when the conversation was about gossip, at the end of this conversation, they measured the hormone levels of this participant. And if the conversation is about gossip, then the oxytocin levels increase. Now, I'm not sure if you know what is oxytocin, but it is an hormone, and they call it the hormone of love. So when someone has an orgasm, there is a large spread of oxytocin in your blood. Okay, so there is some truth in saying it's not stupid at all to say that we have a kind of pleasure in telling things about others, in talking about others, okay, in sharing information about others. And now what we tried to do in our model was combining these two ideas. So first, the idea that we discriminate based on what others do to others, and we also share reputations about others. Okay. So we build an artificial society, okay, so a model where we have agents, and we don't have a nice interface as in Sims, and our agents are not complex at all, but the idea is there. So we have a society, and agents use a strategy. These strategies are very simple, so they tell the agents if they should cooperate or not, depending on the reputations of their opponents. Our strategies will evolve in this society based on imitation. So if an agent perceives that there is another one that is performing better, then this strategy is going to be imitated with a high probability. And a fundamental question here is then, who should be considered good in this artificial society in order to have cooperation? Okay? And this is not a trivial question at all. So we can think about a lot of answers to these, and each answer is actually a moral code or a social norm. Okay? So in this work, a moral code is a rule that prescribes a reputation after an action directed to a certain player with a certain reputation. Okay. So we can think about the most simple social norm ever. So who should be considered good in a society? Nobody. Of course, this norm is really simple, but it's not useful. This does not promote any cooperation. We can try to complexify this a bit and say that, well, people that should be considered good are people that cooperate. That's okay. It's a bit more complex, but a bit more useful. Or we can say that whoever cooperates and defects with bad opponents should be considered good. Okay? You get the idea. So with this very simple formalism, saying that reputations are binary, good or bad, and actions are binary as well, cooperate, defect, if we take into account that a norm has as input an action and three reputations, we can have tens of thousands of different social norms. And the point is that they can be extremely complex. So we can have a social norm saying that an individual should be good if he's already good and cooperates and the opponent is now bad but was good in the past, or cooperates. You see, this can get really, really, really messy. Okay? So the first thing that we did was try to quantify what is the complexity associated with each of these social norms. And I think, so I believe that everyone has a background in computer science, right? Is there someone that doesn't have a background in computer science? Okay, so I think you'll get this idea very, very quickly. So if we look to this, what we are dealing with here are actually Boolean concepts. So we can start by saying that here our ands and our ors are actually logical ands, and logical ors are disjunctions and conjunctions. And if you remember your programming logics for programming course, you remember this notation. And in between, what we have are actually Boolean variables that can be true, okay, I am good, or can be false, I am bad. I cooperate, true, I don't cooperate, false. Okay. So after translating these social norms to Boolean functions, we can have a number that translates how complex or how simple is a social norm. Okay. So in this case, if we count the number of logical variables that we must use to describe this norm, then we reach the number. In this case, we can say that this norm has a complexity of 14. Okay. So now our goal is to relate each norm with a cooperation level, but also take into account the complexity associated with this norm. And the idea is that a norm should be simple, because simple norms are norms that are easy to learn, to communicate, to employ, but they should also promote enough levels of cooperation in society, right? So we are studying social norms in this space here. So again, after simulating, after doing a lot of simulations, so we fix one social norm, we let our society evolve, and we measure the cooperation level associated with the norm. Then we obtain, a whole bunch of norms, cooperation levels, and complexities. But what we conclude is that a norm doesn't need to be too complex to promote high levels of cooperation. Okay. Actually, we can have norms that are highly cooperative while just having a complexity of 4. So remember before, the norm was too complex, so we had a complexity of 14. Now I'm talking about a norm that only has a complexity of 4, and that is highly cooperative as well. And let me talk for a bit about these norms. So this was the norm, the most simple norm that was able to promote high levels of cooperation. Okay. Now this norm is special because of 4 different motives. So first, it's highly cooperative. Okay. So when our society is implementing this norm, then agents cooperate a lot. Second, it's really simple, so we can describe it only with 4 different logical variables. Third, it doesn't use the past. Okay. So we could say that someone is good if cooperates with someone that is good now and good in the past. But we don't need that. We don't need the past to make a moral judgment that is highly cooperative. And fourth, and I think this is the interesting part, is that if you remember the first study with the babies, then you realize that the moral judgment that they were doing was about this, was about picking the characters that were cooperative with those that were good, but also picking those that were not cooperative with those that had a bad reputation. Right? So this was just a quick summary of this work. So this work was published in Nature. If you have curiosity about this, you can try to find the article, or you can just send an email, and I'm really happy to send you the article and discuss with you any other idea. So what I think that it's really interesting about this, and my main purpose, is to understand our social dynamics and our social behaviors. But as a side effect, you can actually relate this kind of works also with web platforms. So if you think about platforms where you have users nowadays, almost all of them are based on a reputation system. Right? So we have reputations associated with users, and you can have the same questions here. So what are the reputation systems that you must implement in a platform in order to have high levels of cooperation while being a simple reputation system that people actually understand? So thank you very much.